Hello, I'm Alyssa Ragazzino, and I'm from Lab Section 02, here attempting to record my video lab report for experiment number 2. So we are going to start with filling in the blank copy of the copper reaction scheme that occurred during the experiment. So we're going to start right here with when we took the copper solid and we added the nitric acid to it, HNO3, and we actually ended up with CuNO3 2. We know this because when added, the compound in the beaker turned bright blue like a water-soluble salt, became very aqueous. So that's why we considered that, like my partner and I. And then along with like the H2O, we then also got NO2 like a gas. This was when we started to burn, like put the beaker on a hot plate and it started to burn. It gave off this brown reddish gas, which is the description for NO2, so that's why we chose that one. Then we did add the NaOH, and we ended up with CuOH2, which was a solid. This solid was royal blue, like a salt. It formed precipitate of a solid kind. You could see it as you were doing the experiment when you were stirring with the stirring rod. And you also ended up with NaNO3 here, which is also aqueous. And it became like a white salt, and it dissolved in the water to like a colorless solution. As we were doing that, after we added the NaOH, we then added heat to it, and we ended up with CuO, a solid. This solid was black. It was like water insoluble solid. You couldn't really see through it at all. It was just completely black. We also ended up with H2O, a liquid. There was like this black solid substance, and then the liquid also in it was water. So then we added H2SO4, and we ended up with CuSO4, which is also aqueous. And this was like this bright blue color, water-soluble salt, aqueous form. Like you could look in the beaker and tell that it was aqueous. So that's why we selected that one. And then on top of that, we also again still had that H2O liquid in there. You could see it. It was like the aqueous substance with water, so you could tell that it was there. And then when the zinc formed, we actually had a couple things happen. So starting up here, we had H2, a gas it gave off. This gas, it was colorless. You couldn't really see it, but you could see it coming off the beaker when we added that heat again. We also ended up with ZnSO4, which was another aqueous sample or substance. This substance was white salt. It dissolved in the water to colorless once again. So we knew it was that because we were getting to the point where it should be turning back to zinc before it was to go back to copper. And then finally, before we got to the copper, like I said, before we get to the copper state, we're in that ZnSO4 state again, the aqueous state, and then we ended up back with copper solid. So that is our copper reaction scheme that happened during experiment 2. So now that we've discussed the scheme, we're also going to calculate the percent yield of copper. So we actually start with recovered mass of Cu over our initial mass. So what we started with, my lab partner and I, is on the bottom, and then what we finished with when we measured it the next day is what we end with. And then we times that by 100%, and that gives us our percent yield. So my partner and I actually finished with 0.582 grams of Cu, and we started with 0.512 grams of Cu. So we are going to end up with some experimental error here. due to a common thing that we'll talk about next. So then we time this by 100%, and we end up with 114% yield. So you might be asking why we got this high of a number. You can actually get this high of a number or this low of a number. It's really pretty much impossible not to get exactly 100%. So there's this thing called experimental error, and it's just any error that can occur during an experiment. You can get less, so you can get like 92%, for example, or get greater like we did in my case, this 114%. Less could have happened when we decanted throughout the experiment multiple times. So I know watching my partner try to do it, it was very tough, so we lost some sample. So that definitely could cause you to end up with less than you started with because you're just losing sample just because of the experiment protocol. Greater experimental error, it could have happened, during this experiment we were cross-contaminating a lot of chemicals together. So using so many chemicals that we could have actually not had the right exact amount, causing that experimental error to be greater than 100. So if we put too much of a solution or too much of a powder to start with, that's how we could have ended up with this 114%. So that is our experimental error for this experiment. And then our references for this experiment, it's just going to be the Chem 110 and Foundations of Chemistry Lab Manual of the University of Mount Union in Alliance, Ohio, 2019, and it was written by all our chemistry professors' names listed here. We used pages 7 through 11, and it was Appendix A and B also to learn how to cite. So yeah.